Hello, Internet. Today, a very simple question. Imagine you are going to your doctor, and the doctor is using a neural network AI to detect cancer in mammography images. Even if this image processing model seems to be performing well, the whole AI system might be focusing on image features that are accidentally correlated with the tumors rather than the actual signs of tumors. And yes, you have guessed it, we are again in the feature attribution area. And this is the reason why I showed you how to code feature attribution in Python so you really understand what is going on when an AI takes a decision and says, well, with a high probability, I detect signs of tumor in this image. So to help solve the problem if the system is working or not, and it is currently February 2022, the MIT researchers set out to evaluate this. And the findings that they had is that even the most popular methods often miss the important features in an image. And some methods barely manage to perform as well as a random baseline. Now, they specify that this could have major implications, especially if neural networks are applied in high-stake situations like medical diagnosis. If the network isn't working absolutely properly, 100%, those attempts to catch such anomalies aren't working probably either, and human experts may have no idea that they are misled by a faulty model. And just to give you an idea, I put here on the right-hand side ArXiv preprint, and this is from October 2021. And this is also about the effectiveness of feature attribution methods and its correlation with automatic evaluation scores. And it is a very interesting preprint, a paper, explaining the decisions of an artificial intelligence model that is increasingly critical in many real-world high-stake applications. But despite humans being the target end user, most attribution methods were only evaluated on automatic evaluation metrics. So they set out to conduct the first ever user study to measure the effectiveness in assisting humans in classifications. And they found automatic attribution map evaluation procedures to correlate poorly with the human actual AI team performance. So you see, there is actually a place, a time where we have to say, okay, our methods do not work properly with a certain degree of confidence that every patient would expect. So we have further research to do. But what is interesting, and let's go back here, jump back to the MIT publication. Well, yeah, they especially alarming results. So the results are not encouraging, none of the feature attribution methods, and they checked out for quite some of the methods, got close to 100%. Well, nobody expect 100%, but most barely reached a random baseline of 50%. And some even performed worse than the baseline in some instances. So this is the non-optimal version of what we want to see with our models. They say all feature attribution methods they studied were better at detecting an anomaly than the absence of an anomaly. So this means they could find a watermark on these medical images more easily than they could identify that an image does not contain a watermark. So this is the problem with negative predictions. And they showed that it is critical to test feature attribution methods before applying them to a real-world model, especially in medicine. And moving forward, the researchers want to use the evaluation procedure to study more realistic features that could lead to spurious correlations. So this is Also a very necessary insight, some really important evaluation methodology to find out how well do our explanation methods for machine learning models work right now, January, February 2022. And even if we use these feature attribution methods, how good are they? How much confidence can you have as a patient that if a team of physicians is using a neural network to detect, for example, cancer in mammography images, that the neural network is really augmenting the human insights for your diagnosis? This was the first example, but let me show you two further examples. In this newsletter by protocol.com, Andrew Nang said that manufacturing industry will need tens of thousands of unique AI models for each and every unique type of product and imperfection. Imagine. And David Dewhurst, the vice president of marketing, says, when systems are built for models that were not trained with company-specific visual data, they mistakenly will flag something that is not an error as an error, and vice versa. In this article by VentureBeat from January 2022, David Allison from Lenovo talks about responsible artificial intelligence and about the ethical, legal, safety, privacy, and accountability concerns. And this ranges from balancing your training dataset, assess the impact, to record the quality of your input data, to measure and evaluate all the risks, and even if crossed with some external data, does it violate your individual privacy?